Hello. I had the camera fixed, but I had it fixed for photos. I don't know if that's, let me see. Can you see? All right. So, hi, how are you doing? Almost happy Thanksgiving. Happy Thanksgiving tomorrow, you guys. Yes. I'm setting a timer. Yeah, believe it or not. So, hi, happy Thanksgiving. Hope you're having a good time. Thought I'd throw a little video up before we before we go. Excuse me. And I know last time we left, I believe we were working on something like this. That was two. I always got some color that don't want to cooperate, don't I? Can y'all see that? Can you see the two? And then we had 6y minus 3z, I believe. I believe that's where we left off at. So, when we were talking about, I was telling you about distribution and how these parentheses are not just grouping symbols, but they also imply multiplication. So that means you'll multiply this 2 times everything inside the parentheses, right? So you'll go 2 times 6y, because remember 6y is a variable term. You can't separate those. We just don't know what y is right now. But we can't just leave it out because we don't know what it is. But we can handle the 6, right? And then we'll also distribute and multiply that 2 times negative 3z, right? Because your sign is always going to be in front of your number. So a number can't have 2 signs. It's only going to have that one sign, okay? So 2 times 6, 12y. And 2 times negative 3z, negative 6z. And that is it. We can't combine these because they are not like terms, but we have simplified this expression, right? Did I show y'all the tic-tac-toe for multiplying and dividing integers? I'm pretty sure I did, but you know me. Leave it up there on the board, right? Draw yourself a tic-tac-toe. Do a diagonal positive, right? Fill the rest with negatives. And then again, any way you read it, top to bottom, left to right, right to left, bottom to top. This is for multiplying and dividing integers. Right? Multiplying and dividing integers. So right here we had that 2 times that negative 3z gave us that negative 6, right? Our 2 is positive. Okay? And I think I had one more picked out for you. I heard it in my head. Don't erase it, don't erase it. Okay, hold on. Again, you just make your tic-tac-toe, diagonal pluses. Excuse me, and the rest with negatives. I left my water back in my office, so I should have brought it with me. Okay, so I had one more picked out for you that I thought would be really fun and interesting, right? Actually, let's do a couple, right? Okay, so we have 2 times z minus z squared plus z to the third, all that's together, plus 3 times z minus 2 plus 9 times negative z plus 5. All right, so I hope we can see this whole board. Hold on, let me cheat. Let me check. Okay, it looked good to me. So, what are we going to do first, right? We're going to distribute. So yes, that means we're going to multiply this 2 times each term inside the parentheses. And once we've distributed the 2 to each of the terms, we can drop the parentheses because now we're not holding those items together. Right now we're holding all these together and we're like, we want all of these to be multiplied by the 2. Then after we do that multiplication, oh, okay, we gave the 2 to everybody so we can let it go. It's like a hug, right? I'm going to hold all these, and once I gave you the hug, which is the 2, then we drop our arms. In this case, the 3 is hugging the z minus 2, right? This is z minus 2 or z in negative 2, right? There's z minus 2, and this one is hugging the negative z plus 5. That means the 9 is going to go to that one, right? So again, we're going to distribute. The 2 is going to go to the z first, negative z squared second, and positive z cubed the third term, right? So that's going to be 2 times z. We don't know what z is, but we don't have to know what z is. We just know that z is our variable. So it's going to be 2 times z, which is going to be 2z. And then 2 times negative z squared. Again, we don't have to know what z is because whatever it is, we're multiplying it by 2. So negative, oops, I forgot that 2. Negative 2z squared. And that means this 2 again. Now we're taking this third one, the positive z cubed. So positive 2z cubed, right? And we're not done. So we also have this, and we're adding whatever this whole term is to this. So then we're going to do the same thing because rules do not change. Ever, 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 math rules, let me say that. Math rules do not ever, ever change. So we're going to distribute, right? That means we're going to distribute this 3 to the z, and then we're going to distribute the 3 to the negative 2. When we do that, we get 3 times z. It's a positive, so plus 3z, and then positive 3 times negative 2, it's going to be negative 6. And then one more time, we're going to have to distribute first. 9 to negative z, and then that 9 to the positive 5, right? So then we have 9 times negative z, negative 9z, and 9 times positive 5, positive 45. You're like, whew, we're done. No, no, no. Right now, we're in the process of simplifying, but simplifying involves combining like terms. Remember? Like terms, those are terms that have different coefficients, but they have the same variable part, and the variable part has to have the same exponent. So now we're going to look through all our terms and see if we can see anything, what our variable is. We notice our variable is what letter? Z. So our variable is z. And then do we have any variables, the z variables with different exponents? We have a z squared to the second power, that's the 2. And we have a z cubed to the third power, that's the 3. But we also have this z right here, and when you don't see a power, just know there's an understood. It is understood, not imaginary. Imaginary is something completely different, but it's an understood to be a 1 there. And so yes, again, rules don't ever change. That means each of these is understood to have a little 1. When you don't see the power, that automatically means it's to the first power. Okay? So we look and we have 2z to the first power, that one's squared, that one's to the third power. We have a positive 3z to the first power. Then we have some numbers right here, right? Just a constant value because this is just negative 6. And we have a negative 9z to the first power. Then we have another constant value, this positive 45. So we have this, well, I'll do that in a different color. We have this constant value and this constant value. And remember, they're called constant values because that's the value that they're giving you. This is just negative 6. It's not being multiplied by a variable, so it doesn't have a value that's changing next to it, right? it's just 6. And the same for 45, it's just giving you positive 45. But we can combine all of our like terms. So when we separate that, we see that we have a positive 2z, and we have a positive 3z, and we have a negative 9z. Positive and positive. So again, what's the rule for adding and subtracting integers? What's your rule? What's the rule for adding and subtracting your integers? Okay, the shortcut is, remember, and I think we already talked about this, if the signs are the same, we add the values and keep the sign, right? So if the signs are the same, we add the values I know what I said about it equals, but that's an equation. We add the values and we keep the sign, right? That's not an equals, that's a negative. So it would be negative 11. And in this case, we're adding the values. So this is for when our signs are the same. What about when our signs are different? What about when we have different signs and we're adding and subtracting the integers? What do we do for different signs? Can y'all still see that? Might have to get a new orange. So for different signs, we subtract our values. It looks like orange, right? Subtract values and apply the sign of biggest number. Or the biggest value, right? So we have different signs. That means if we had, this is a negative, this is a positive, so we're going to subtract our values. Just wanted to make sure it equals to 6, right? And what do we have? Since 14 is positive, that means our answer is positive. Yes, that means that if we had negative 15 plus 9, we would still subtract our values. And because 15 is bigger, then the 6 is negative. Okay? So those are your rules. So back to combining these like terms right here. The 2 is positive and your 3 is positive, so we're going to do what? Add and keep the sign. 2 plus 3 makes a positive 5, right? So now we have 5z minus 9z. The signs are different, so we're going to subtract our values and apply the sign of the biggest value or the biggest number. 9 minus 5 is 4, so that's going to be a negative 4z. Okay? So as far as our z values are concerned, this one and this one and this one becomes negative 4z. So I'm going to rewrite it over here. I don't have that big board. I'm going to rewrite it over here though. And what I'm going to do, you're going to see me change the order of these. And as long as the sign stays with the value, it's okay where you write it. When you're doing addition and subtraction. When you're doing addition and subtraction, again, yes, these are stipulations to these rules. I tell you, if there's stipulations, I make sure to tell you those, okay? But as long as you're adding and subtracting, you can write it, and you can write it where you want, and you keep the sign with the number. That's because things like 4 plus 5 is the same as 5 plus 4. However, 4 minus 5 is not the same as 5 minus 4, right? Because this is positive 1 and this is negative 1. So the sign has to stay with that value or you're changing stuff. And I told you, you can't just change things randomly. You can't cut a circle or a zero out of a magazine or newspaper and stick it on a $1 bill and call it a 10. That's what you do. If you just leave things or you just change signs randomly, that's the equivalent of doing something like that. Cutting the circle out and sticking it on a dollar and calling it a 10, okay? So don't leave things, don't change values. You can change the way it looks, but you can never change the value, okay? When I say you can change the way it looks, like 4, you can write that as square root of 16. You can write that as 2 squared. You can write that as 8 divided by 2. All of those are value of 4. So you can change the way it looks, but the value is still 4. Okay? All right. So we're going to go ahead and we always want to put it in descending order, right? Descending like you're going down the stairs. So it's going to be the toppest, the biggest, and then goes down, right? So the biggest exponent we have is the 3. So we'll rewrite this with our combining like terms of our z variable. We'll rewrite it as 2z to the third. We got that one. And then we have negative 2z squared. We got that. And now we know that these z's are now negative 4z. Then now we just have to worry about our constant values. And what is a positive 45 and a negative 6 combined? Which rule are we going to use? Are the signs the same? Or are they different? All right? And so 45 minus 6 is what? Now we are done. Final answer. We have simplified our expression. And that's as simple as we can make it because we don't have any other like terms to combine. Okay? Give you a few minutes to write that down. In case you did, in case I moved a little fast for you. Oh, what? I'm moving slow. I'm just kidding. I kind of felt that a little bit, but you know what? All right, so I'm going to step it up just a little bit more. I feel like we've done this already. Did I show y'all how to do the fraction things? I feel like I did that already. You know, I think so. I think we were solving linear equations with one variable. Did we move to solving linear equations with one variable? If we have, oh yeah, we did, because I talked about a line, right? Okay. So, let me erase this. Let's see what we got here. You can never have enough, right? You can never have too many examples. I can't. That's why I have all those math books in my office. Okay. So, we were doing linear equations in one variable, and I think we were actually supposed to be solving one-step equations, right? So, let's see. I'm going to take this down, and we're going to move to, and I said, what? I said, solving right? And now that I write that, like I said, I remember talking to you because the root word of linear is line, right? And we talked about the root word of equations is equal. And so I'm just going to throw, okay, so here's some things. Here we go. We're going to get into the nitty gritty of this math, of the solving these equations and stuff like that, right? So we have some properties that you need to know. ADDITI, additive inverse property. All right. The additive inverse property states that when you add the inverse of that value, you get 0. So anytime you want to make it 0, you have to use the additive inverse. What does that look like? That means 3, you start with a positive 3, right? And what is the inverse? Inverse means opposite. And so a positive 3, we're going to say minus 3, right? A positive 3 minus 3, what's that going to leave you with? 0, right? So if you look this property up, you'll see it like this. Plus a negative 3. Ooh, 20 minutes is up. Okay. Dang, I was just about to get into this. That means I have about 9 more minutes left on my camera. Okay. So you'll see it like this because they add a negative. And adding a negative is the same thing as subtracting, okay? You have that's probably some of the tricks up in math is recognizing that they'll say things fancy ways, but all it means, adding a negative is the way that you subtract. You're adding a negative value. When you add a negative value, that means you're subtracting. Okay, so the additive inverse property is property 1. Property 2. Now, what do you think the additive inverse property works with? What mathematical operations? You know, there's 4 mathematical operations, right? There's only 4. Everything you do in math is one of those 4. Right? Add, subtract, multiply, and divide. Okay? 4:30, we'll be closing in just a few. So the additive inverse property has to deal with what? What operations did you use? Addition and subtraction. Okay? Then we have property 2, multiplicative. Is it multiplicative? Yes. Multiplicative. T-I-V-E. Multiplicative inverse property. Okay, multiplicative inverse property. I'm trying to go too fast. I'm going to mess up on my spelling. Multiplicative inverse property is how you get the value of 1. And so what that means is that if you multiply something by its inverse, the inverse in multiplication, the inverse of this we call reciprocal. Inverse always, of course, means opposite. So if this is 2 over 3, the opposite would be 3 over 2. Again, that's called a reciprocal. Reciprocal, right? But basically what it states, again, if you use a multiplicative inverse, you get 1. And remember the additive inverse property, you get 0. Right? And so again, that's because you know anything divided by itself is equal to 1. 2 times 3 is 6. 3 times 2 is 6. 6 over 6 is the value of 1. So anytime you need the value of 1, you can always use the multiplicative inverse property, okay? So again, I told you guys when I started out doing this, I was telling you that we use so many rules and so many things, we forget what they're called and we forget what they are, but you're so used to using them, what happens is you read it in the book or they'll state it and you'll be like, wait, what is that? And then your brain kind of searches for it and you just get all confused and foggled up. Right? So here they are. And I advise you when you're working your math, and I always say go step by step. Only evaluate what's on the paper, 1 change per line, and tell yourself what you're doing. This is, okay, I'm using my inverse right now, using my multiplicative inverse, I'm trying to get 1. Like, just talk yourself through it. And the more you do that, it's going to become repetitive. It'll become second nature. It's like, you know, driving. You don't even think when you're driving now. You know that the foot and the steering wheel, all of that coordinates together. Walking and talking and chewing gum. I mean, it coordinates together because technically it took you 365 days to learn how to walk. To put one foot in front of the other. Right? So be patient with yourself, but be consistent with yourself as well. All right? So then this one is super important. And this is why whatever you do to one side, you have to do to the other. And that is the additive identity property. No. I'm gonna skip. Addition property of equality. I'm gonna skip to that one. I'm gonna skip to that and then I'll go back. Mind you, okay, I skipped over the additive identity property, the multiplicative identity property. The additive identity just says if you add 0, then you get what you started with. The multiplicative identity says if you multiply by 1, you get what you started with. But please go look those up. Look those up on Google, okay? The additive identity property and the multiplicative identity property. But what I'm going to go over you with right now is the addition property of equality. Oh God, that 5 minutes is up. So it says that when you have numbers, let's just say that you have, if as long as A is equal to B, if this value and this value is the same, right? Then A plus C is going to equal whatever B plus C is. You're like, I don't know what that means. I don't know what that means. But it just means that these are 3 real numbers, A, B, and C, and that A and B is the same. But basically, whatever you do to one side, if A and B are the same value and I add C over here, then I have to add C over here because the equal said that these are the same. Equals means is. This is this. So if A is B, and I come back and I add C to A, then I have to add I have to add C to B as well because they're the same thing. So that's where you get this. And then this is added, so if you take it off one side, you have to take it off the other. Okay? This is where this rule originates from. All right? So we're going to end there because my time's about to run out. Look, I stopped the video before it stopped me. And I will see you guys. Enjoy your Thanksgiving. Please, if you have questions, put them in the comments. I'm a little bit more accepting now. I'm okay. You can tell me you don't like it, but that's fine. You do. You keep watching. I'm just kidding. Let me know. Okay? Enjoy your turkey day. Have fun. Be careful out there. And thanks.